brief introduction. Christopher is an architect. He is part of our leadership team and has been with us for the past, 4 years?
5 years.
5 years.
Didn't know you were having that much fun.
Yeah, I didn't, it's just amazing. And he spoke at a conference a couple of years ago and informed us about the fascinating air conditioning that termites do and that some people who imitate termites do. And in very hot climates, they have very cool buildings. And he has taken his creative investigations to the next step and developed a fascinating perspective on cooling the planet. And I'll just let him take it from there.
Thank you, Adam. Good morning. I'm Christopher Haines. My presentation is called Heat Planet, Biodiversity, the Solar Interface, and Climate Disruption. This presentation, I'm inviting you to take a stroll in the Paradigm Mountains. If you want to make small changes, you can change the way you do things. If you want to make major changes, you have to change the way you see things. And I'm inviting you to see things differently. Page down. The reports in 1979 codified the greenhouse gases as the cause of global warming. The Jasons, who have been described as a mysterious coterie of elite scientists, published the long-term impacts of atmospheric carbon dioxide on climate in April of 1979. And because the Jasons were the Jasons, it got a moderate amount of interest to the point that it came to the attention of the Carter administration. And they asked the National Academy of Science to review the Jason report and tell them whether, in fact, this was valid. The National Academy turned to Jules Charney of MIT as a well-respected climatologist, and they published the Charney report in September of 1979, Carbon Dioxide and Climate, a Scientific Assessment. From that point on, we've been blaming the pot lid for the pot boiling over. This is about how about turning down the stove. It's a story about sunshine, how the sun impacts the planet and how the actions we have taken in changing our planet change that impact. Solar energy comes from the sun. The center curve on this is the visible light spectrum, which is what we actually see. The upper curve is the very short wavelengths of solar energy, the chemical intensity. Some of those wavelengths are extremely hazardous to life, human life and other. The lower curve is the thermal intensity. It's the high heat infrared waves that you feel as burning from the sun. Obviously, photosynthesis is the process of creating sugars from carbon dioxide, water, and energy from the sun. You get basic sugars and oxygen. And that is the way plants produce the bottom of the food chain that everything else on the planet depends on in one form or another. There's an efficiency factor here called the leaf area index, which is the ratio of leaf area to the surface area of the ground that plant covers. The higher that ratio goes, the more effective, more efficient the plant is being in capturing sunlight and converting that to biological energy, which is pumped into the ground. As plant food, it actually goes to fungi and it gets more complicated from there. But creating sugars for plant growth is only one of the things plants do. If you note the photo on the right, in the case of moisture, 70 to 80% of the energy of the sun is transferred into evapotranspiration, what we call latent heat. It is converting water into vapor that produces a cooling. And in that case, only 5 to 10% is actually sensible heat, which is the heat you can measure with a thermometer as temperature. If you notice the drain field on the left, the sensible heat is the vast majority of the heat being generated, with only a small amount of evapotranspiration occurring. This is the Amazon rainforest, and these are the billows of moisture rising off the forest as this massive amounts of transpiration occur. It's been calculated that about 2/3 of the solar energy hitting a tree canopy produces this transpiration and water and cooling. You can see this in numbers, these courtesy of K. Brown. On an afternoon when it was 94 degrees air temperature, it was 10 degrees cooler under leaf cover. That was both the function of the shade and the function of the whatever transpiration the plants were producing. It was 13 degrees hotter on bare soil. And as you can see, that the higher temperatures drastically reduce the effectiveness of water, its use for plants. And so there's a downward cycle in losing water capabilities. Jen Lambert talked about that last week and did a very good job of it. So we know sun warms the Earth's surface. You've all been here. Summer afternoon, shady, very pleasant walking through woods. The transpiration, the cooling affected by the trees, and the shade protecting you from direct sunlight. Now, if you take a walk in that meadow in the upper left, your feet get shaded a little bit. There's a little bit of cooling being provided by the transpiration of the leaves, but it doesn't go very high up your legs. On the other hand, if you walk across the sand or the parking lot in the upper right or the plaza on the lower right, which was designed for people, but it's not too surprising there's nobody in it. You may have seen this in other forms. The upper left is a 4x4-inch wooden post that's holding up a mailbox. But as you can see, the post has absorbed the energy of the sun, warmed the wood, and re-radiated that energy as heat to melt the snow. The lower right is a double 4x4 post holding up 2 mailboxes. The lower center is a telephone pole, so it's a larger wood, but it's done exactly the same thing. The upper right is a rock, and the lower left is a cast iron fire hydrant. But in both cases, they have absorbed heat, re-emitted it, and caused melting. So the heat pattern is visible. Okay. I won't go into the material physics that files all this, but this is an infrared photo of a plaza in Czechoslovakia where the colors reflect the temperature. And as you can tell from the chart on the right, the roofs are very hot. The facades and the paving in the plaza are quite hot, and the trees in the background are quite cool. There's a very major difference between the temperature of the roofs and the temperatures of the trees. This is the Earth's energy budget. This is a NASA image. The sunshine comes down to the Earth. About 30% of it is reflected. About 20% is absorbed by the atmosphere, but the majority warms the Earth. The Earth, as it warms, radiates energy out as infrared, which is the heating version, into the atmosphere. The warmed atmosphere, the atmosphere absorbs infrared radiation rising from the Earth's sun-warmed surface. This is the American Meteorological Society. So we know the sun warms the Earth's surface, heat from the planet warms the atmosphere. Jean-Baptiste Joseph Fourier was a French mathematician and physicist who in the 1820s, in studying the solar energy that arrived on the planet, realized that if it were not for some form of insulation holding heat into the Earth, we would drop well below freezing every night. So he didn't understand the mechanics of it, but he was aware of studies others has done on the heat trapping characteristics of a glass box. He compared the atmosphere to a hothouse, a glass hothouse, which we call a greenhouse. He never used that term. So the concept of greenhouse gases without the mechanics was known almost 200 years ago. This is the greenhouse effect. This is EPA. Sun warms the planet, the Earth. The Earth is warmed, radiates infrared into the atmosphere, just as the NASA photo shows. but the greenhouse gases absorb and re-emit the heat. The effect is they trap heat, and that increases the heating effect on the surface. So we know the sun warms the Earth's surface, heat from the planet warms the atmosphere, greenhouse gases exacerbate the warming, but do not generate the heat that causes it. Luke Howard, British man, the 18th and early 19th century, as a child was fascinated by weather and clouds and would spend hours just staring at the sky. On an evening in December in 1802, he walked onto the stage of the Eskisian Society, which is a local science club, and gave a lecture on the transformation of clouds, in which he defined the classification system of clouds that we still use today. That interest in climate and weather continued, and over the coming years, he was taking measurements of temperatures in and around London until he had published the Climate of London in 1818. This is the second volume done in 1820. City of London, 1800, the census was just under 1.1 million. It was probably the largest city in Europe. It was a hub for youth, and particularly women seeking service jobs of many forms. Massive migration gave neighborhoods specific qualities, which changed at time. Reached 1.4 million by 1815 and nearly 3.2 million by 1860. So as Howard was thinking about how do you explain the increase in temperatures that he was finding in the city as opposed to the outlying areas, he thought about the fires. All the forms of heat that are a result of combustion used for heating houses and for industrial applications and whatever else. He goes through a long list of them. And he noticed that the greatest effect, the greatest difference in temperature was in the winter, with the lowest effect in the spring. And this was consistent with the understanding of the timing of these fires that were leaking heat into the atmosphere, chimneys and all. But the temperature difference increased again in June. It is probable, therefore, that the sun in summer actually warms the air of the city more than it does that of the country around. And as he thought about the major sources of cooling, considering radiation to the sky, fresh breezes to cause cooling, and evaporation caused from moisture, which were all lacking in cities to a great extent, we shall perceive that a city like London ought to be more heated by the summer sun than the country around it. This is the heart of urban heat islands. This is Lisa Garland, the relatively recent book on heat islands. It's quite good if you're interested. And she lists her sources of causes for heat islands: decreased evaporation, Howard said it; increased heat capture, Howard noted it; increased heat storage, again; decreased convection; anthropogenic heat, those are what the fires that he originally started with, although we have more of them, obviously; and systemic interactions. We've learned surprisingly little in 200 years. So we know, sun warms the Earth's surface, heat from the planet warms the atmosphere, greenhouse gases exacerbate warming, but do not generate the heat that causes it. Heat generation by urban heat islands has been documented for 200 years. So it's a question of the utilization of the sun. We have this, or we have this, and this. In case you can't see it, that's Detroit, Chicago, Indianapolis, and St. Louis, and that's an infrared image of an urban heat island. And it gets worse. I don't even remember what city this is. But if you build, we talked about the leaf area index as being an efficiency factor in a plant's ability to capture solar energy. Buildings do the same thing. But all the extra heat they capture, all the extra energy they capture is converted to heat instead of into transpiration and photosynthesis. If you build a one-story building, a small house, the wall area is approximately the same as the roof. So you have doubled the surface area that the sun sees. Yes, some of it is in shade. If you build a standard commercial building, 5-story commercial building, the wall area is about 4 times the roof. So you've now increased it 5-fold. And a 50-story office building, the wall area is about probably 20 times the roof. So it doesn't take a very large city to have a total surface area that is 5, 10, maybe 20 times the footprint of the city on the landscape. The upper graph shows greenhouse gas levels. They've increased 30.85% from 1800 to 2000. The lower left is the urban footprint in square miles. From 1800 to 2000, they've increased 3,345%. And urban population in the same time frame has increased 3,836%. So we know sun warms the Earth's surface, heat from the planet warms the atmosphere, greenhouse gases exacerbate warming but do not generate the heat that causes it. Heat generation by urban heat islands has been documented for 200 years. Urbanism has increased more than 100 times faster than greenhouse gas levels. A rural heat island? Well, an island is by definition typically a piece of land surrounded by a border of water, which has a fairly distinct border. There's obviously room for tides. So this is an urban heat island. Can somebody tell me where the border is? We define an urban heat island as a warmed area near the core of the city that is warmer than some outlying area some distance away. But as should be clear from this, everything is impacted. The sun shines everywhere. We have no zero zone to measure an urban heat island against, which means we have historically been underestimating the heat capacity of urban heat islands because we're measuring them against something else that is also increased in temperature, though obviously not as much as the urban center. The picture on the right is a small cottage. It's actually in Czechoslovakia. But is that a heat island? It has a tile roof. It has stone steps. It appears to have one individual. I can't tell what the siding is, but it's probably wood. It's sitting on a drained field. We looked at that in terms of photosynthesis and water. That the grass itself, if it doesn't have a lot of water, is producing a lot of sensible heat. And so the answer is yes, that is a heat island. Very small. It may be so small you could not detect its presence, but the physics of the sun says that is generating heat that is not being absorbed into photosynthesis and transpiration. This little tree house on the left, infinitesimal, but again, that's a heat island. The wood, like the wood in the post-melting snow, is absorbing energy and re-radiating that energy as heat into the atmosphere. We have about 30,000 square miles of transportation infrastructure in the continental US. The three upper and left pictures to the right are just roads, giving you a sense of them. The lower left is the road in front of my house. A year ago in March, we had a 14-inch snowstorm in the middle of March, and the plows came by and put snow banks on both sides of this road. The bank to the left, as you can see, is pretty intact. It's melted some from the original snowfall. But the road, and that faces due south. The bank on the right, facing due north, is drastically reduced in size. It's probably not more than a third as large as the first. So it certainly appears that the heat from this road, and I can give you all the specifics of it, but it doesn't matter, is melting that snowbank. So we know sun warms the Earth's surface, Heat from the planet warms the atmosphere. Greenhouse gases exacerbate warming, but do not generate the heat that causes it. Heat generation by urban heat islands has been documented for 200 years. Urbanism has increased more than 100 times faster than greenhouse gas levels. The physics apply everywhere the sun shines. Bare soil. The industrial agricultural system produces massive amounts of bare soil for 5, 6, 7 months a year when crops are taken off and nothing else is planted. Even when it is planted, this is a lower left, is a cornfield with about roughly 2 feet of bare soil between the plants. As the plants grow, they start to cause some shading, but there's still an awful lot of bare soil, and there's massive amounts of corn, soybeans, and cotton, which are 2 other crops that produce massive amounts of bare soil between the rows. And the upper right, we've just got sand, we've got deserts, and we have massive amounts of erosion as we've misunderstood the water cycles Jan talked about last week. This is Mauna Loa. It's the measuring station in Hawaii that Charles Keeling started in 1958. The lower left is October 2017. We started at about 404 parts per million. And during the winter, the fall and the winter and the spring, without plants growing in the northern hemisphere, we rose about 8 parts per million until mid to late May. As plants started growing and absorbing, sequestering carbon out of the atmosphere, the levels dropped about 6.5 parts per million down to 405, maybe 405 and whatever, or 406. So we had an increase over the year of about 1.5 parts per million. But this makes it very clear that if we had more land growing more vegetation, that curve going down from May to October could easily have gone much lower. Deforestation. We're losing about 12 million acres of forest every year, leaving bare soil, rubble, generating heat. This is mountaintop removal. The little image on the upper left gives you an aerial picture, gives you a sense of scale, but massive amounts of destruction. And this is now capable of nothing but generating heat. This is Queenstown, Tasmania, Australia. In 1882, they discovered silver, and they started silver mining. By about 1892, they discovered a much richer vein of copper, and so they dropped the silver and started mining copper. The copper, however, was badly polluted with sulfur, and the smelting of the copper ore and the sulfur produced sulfuric acid, which killed everything in the whole valley. I was there in 1994, 100 years after they had been smelting copper, and there was literally not a green leaf anywhere. So we're taking a green valley and turning it into a heat planet. Desertification, we're losing I think it's about 30 million acres a year to desertification. Anybody familiar with that picture in the upper left? That boat is several miles from the coast. We're losing farmland. We've certainly got the southwestern deserts. But all of this land is just generating heat. It's got no capability of producing life, moisture, evaporation. Sun warms the Earth's surface. Heat from the planet warms the atmosphere. Greenhouse gases exacerbate warming, but do not generate the heat that causes it. Heat generation by urban heat islands has been documented for 200 years. Urbanism has increased more than 100 times faster than greenhouse gas levels. The physics apply everywhere the sun shines. The destruction of biodiversity generates heat. We have created what is effectively a global heat island. The destruction of biodiversity, the growth of urbanism, and anthropogenic heat sources are the true cause of global warming. Greenhouse gases exacerbate the problem, but do not cause it. There's nothing I'm saying here that says solving the greenhouse gas problem isn't important. It clearly is, but it's not the cause, and we need to address the actual cause. This is very good news. It produces a world of opportunities to reverse warming. The problems are largely local. Results can be nearly immediate. Regenerative agriculture would be a win-win-win. Cities are complicated, so discerning solutions and implementing them will take time. The paradigm threatens many cherished beliefs, but resolutions could be enlightening. Sea level rise will still be global, but cooling efforts could slow it. This is Canberra, Australia. It's the National Capital Territories. It's an aerial view. You get a sense that this is a city. 400,000 or something of that order, I think. The upper right is the US consulate in Canberra, so you can see the setting for the buildings there. The upper left is the Australian National Library. It's not what we now consider a walkable, sustainable city. Everybody that's pushing urbanism as the solution is looking at consolidated, walkable cities. But it is 12.5 degrees Fahrenheit cooler than urban areas 2 miles away. Thank you.
Thank you, Christopher. We have about 15 minutes for questions. So why don't you put questions in the chat, or you can also just speak up if that doesn't get too disruptive by too many people speaking at once.
Stop the share.
Yeah, I did it, Christopher.
Okay,
You're all set.
Now, I still have a screen in front of me I can't get rid of.
I don't know that I can help you with that.
Well, there was a stop share that has disappeared. I can't.
That's because I stopped it.
Oh, well, I still have a share that I can't get rid of.
I don't know.
Okay, well, we're sharing again. Okay, stop share. Okay, now we're going.
Rock and roll. So if anybody has any questions, why don't you just speak up?
I traditionally ask for questions, comments, or snide remarks, so we can take everything.
Well, I have a snide remark. I thought that was a great presentation, Christopher, and congratulations. Thank you for such
Thank you, Fred.
Such a nice job.
Yeah, Fred, you're going to have to improve your snide skills.
Maybe I could do a little bit better, and with lots of respect and love, because I think that was an excellent presentation. But I kind of knew that already. So what's the takeaway? Like, what do I do differently tomorrow to take action on that?
Well, I'm planning on running the workshop this afternoon to discuss exactly what the ramifications of all this is. I couldn't do both of those in one presentation.
Fair enough.
A quick hint, Christopher?
A quick hint is you have to look at it from that paradigm and start asking yourself questions. For example, renewable energy also generates heat. So it's not the fact that it's renewable that matters. What matters is the efficiency with which it's used. That gets complicated.
Very, especially when you're trying to keep 7 billion people alive and fed.
Well, I understand all of that. My sense is that the greatest opportunity is regenerative agriculture. We have several 100 million acres of land that is being very poorly managed because of industrial agricultural systems. My hope, and I'm not a research center, I don't have millions of dollars to go into this and not quantify every bit of it, is that if farmers turned exclusively to regenerative agriculture and stopped the bare soil, started building fungi colonies, got the water cycle right, that we would cool the country at least dramatically. And perhaps the small percentage of land that's actually used for cities wouldn't be such a big problem. If we have to address cities, obviously the horizontal surfaces are far easier to look at than the vertical surfaces, and will be much cheaper. Horizontal including green roofs. So that's, I think, the first place to address it, but there should be no concrete, no brick anywhere that we don't absolutely need it. So how do we do that? It's not easy. This is, I haven't got any simple answers for you. I'm writing a book on this topic, and I've been working on that for quite a while now, and I keep running into sort of real problems that we have to address. But I think there's room for some creativity in doing this. And the good news is, if you tear out an old parking lot that wasn't needed, it's going to be cooler tomorrow. We don't have to wait 100 years for the greenhouse gases to change it. Now, one parking lot isn't going to change Cambridge. But everything you do will make a difference, and it will make a difference immediately. It's like removing that little treehouse. It was a heat island, very, very small, infinitesimally small. But if it wasn't there, it would matter. And so I see that we actually have the possibility of turning things around in a decade. But it's going to take some very serious work. And as I said, it's going to address some very real priorities that we have held for thousands of years. And we're going to have to do some real careful rethinking about how do we do this? If we now know this, what do we do with it?
So Quentin, we're going to have to somehow induce Cantabrigians to do with their driveway what you did with yours. And
well, I'm ready. So I've linked in you, Christopher, and I look forward to doing more.
Thank you.
Thank you.
Other questions?
Yeah, it's Sue Butler here, and I've got a question. Aside from rescuing the trees of Cambridge, I hear that urbanization is overall a positive climate thing because it's centralizing population, and that if we either used regenerative agriculture in the fields or did E.O. Wilson's half Earth kind of proposal, would the moving of populations to the cities in combination with better regenerative practice outside of the cities overall provide a positive balance like we're looking for?
I don't know the answer to that. My hope is that regenerative agriculture will be really good for farmers, be really good for farming communities, and has almost basically a negative cost if you look at people like Gabe Brown. And so that is where I think the first focus needs to be. I don't have a good solution to suburbs and cities. I'm still working on that, and maybe I'll figure it out in the process of writing all of that. Mm-hmm. But cities, the way we have defined them as sustainable, have serious problems. Can we maintain cities by changing construction, by modifying vertical green walls, et cetera, maybe. I'm sure there will be a massive amount of questions and ideas. One of the things that I see is that if communities adopt this, they have the opportunity to produce, well, say, friendly competitions. Let's see who can cool our town down farthest.
Yeah.
At the same time, they have the opportunity to share successes. We did this and it worked really well.
Nice. Yeah.
So I see a possibility for both sort of friendly competitions of how to do it better, and how to share those ideas and spread them. Right. Obviously, it will change whether you're in the Northern Hemisphere, the Southern Hemisphere, the US or Russia or China or India or whatever. Climates will matter. So there's a lot of variability. These are principles. It's a recognizing that greenhouse gases don't generate heat, and we have a warming problem. This is the stove we need to turn down. And then figuring out how we get there. And I don't have all the answers. I will have a fair number of them down by the time I get the book published, but that's still in progress.
It's a superb presentation. Thank you. And building networks for shared learning are, I think, like this, are wonderful. Thanks very much.
Well, Christopher, it's, you know, there's one point that you made, a central point that I think is important to keep in mind, and that is, and this is something we can all have an effect about, which is that if we believe that the problem is greenhouse gases and carbon dioxide in the atmosphere, then we're completely focusing on the wrong issue, and we're not going to solve it until we recognize the central theme of biodiversity for a livable climate, which is that ecological restoration is the means to address this problem, and that's where we should focus.
That's true. There's nothing I say that says greenhouse is not important. It obviously is a problem. We need to address it, but it's not the cause, and it is not the sole problem that we should address. We've been ignoring the real problem of biodiversity and urbanism.
I'm wondering whether our previous speakers would be able to talk about how much of your ideas are actually already in practice, or at least being discussed in the eco-municipality movement. Because it seems like there's a logical overlap here between what you say and people who are thinking about ecological urban developments. And does anybody have any answers and thoughts about that?
It's totally compatible with what Christopher's saying. You know, all we're saying, all this is we have to think systematically and include human needs in the picture, but, you know, and it doesn't prescribe what to do. It just says, as long as we follow these objectives, and this fits perfectly into those objectives. There's nothing that contradicts it at all. You know, we need more Christophers and more people like this in this conference, just trying to figure out how to spread participation to get these things off the ground.
I thought that Chris's presentation was excellent, but while it moves our focus to what we've done to the landscape and human habitation and biodiversity, it seemed to totally take any focus off of the source, off of the quantity of greenhouse gases we have, and what the source is of those additional quantities of greenhouse gas. It's like, yes, certainly think systematically. No one thing is the sole cause of any of our problems, but you totally ignored our use of fossil fuels, which is in turn related to our use of all other resources to create our built environments, to move us around between them, to create all the products that we use in them. And I'm not saying that we should just worry about fossil fuels and switching to renewables. I'm saying that it's got to be part of the of an overall systemic view of the situation. We must do what everything that you said we should do, along with reducing the amount of greenhouse gases that we emit into the atmosphere. So I trust that you don't that you don't think that this is all we need to do. That what you're doing perhaps is trying to redress an imbalance in our focus.
Yes.
Christopher.
I just want to add one thing to that answer, Howard.
Yes.
And that is our track record with reducing emissions has been overall an utter failure. So given that that's the history that we're building on, how optimistic can you be? And we really need to start emphasizing other things.
Well, then some organizations and some people and some agencies, I guess, are going to have to focus on some things and some on others.
Yeah,
If we did
that's
everything
fine.
that Chris, if we did everything Chris said, we still have to reduce greenhouse gases. We still have to reduce the amount of combustion that occurs to create
Well,
our
there are
energy,
lots of-
and we need to reduce the amount of energy that we need as well.
Absolutely. There's lots of reasons to reduce greenhouse gases. But in the meantime, we have to acknowledge that it hasn't worked. And so we're looking for other things. I'm sorry, Jim, go ahead. And I'd like to have more questions from people who are not part of BioForClimate's.
Well, I just comment, as Christopher was giving his talk, I was thinking a lot about bare ground, and he was emphasizing that. And I think if anybody in this group saw somebody laying on the concrete, unconscious, with bleeding, you know, getting sunburned and bleeding, we do something about it. But if we see our land exposed to the sun, if we see the soil exposed to the sun, if we see bare ground and we see the land bleeding into the rivers and making mud, we don't do anything about it yet. Some people do, but that's how we have to look at the land. That is killing us. The bare ground and the mud leaving, and it's an incredible loss of investment. And I'm really glad Christopher is kind of helping us think about that. So.
I'd like to say something. I'm wondering if we shouldn't give up on cities. I'm very much for using green methods to deal with our lawns and get rid of the chemical fertilizers that are presently going on our lawns that don't allow for any carbon sequestration. With carbon sequestration, these two issues overlap, and it means actually we're doing good in many ways. Do you want to respond to that?
I certainly agree that all the chemicals are a major problem. So it's regenerative agriculture for farmers. It's also regenerative agriculture for everybody else. Natural species, I'm not sure if it's a question of native species for lawns. Maybe it is. It certainly is an issue about deep-rooted grasses as opposed to the mats that people use and try to keep green. The insecticides, the fungicides, the biocides, the fertilizers are all terribly difficult. Nitrogen fertilizer is a fungicide. So you immediately destroy the opportunity for the fungi to provide atmospheric carbon to your plants when you put a nitrogen fertilizer on it, or doesn't completely do it, but it drastically changes the chemistry of the soil. So there's many things involved here, and I'm working on it.
So it's time to break for lunch. Thank you, Christopher, for a great presentation. And
thank you, Adam.
when everybody comes back in about 10 minutes, if you can make it, 10 to 15 minutes.
12:30, right at 12:30.
Right at 12:30, Jim says. So Jim will spend a couple of minutes telling you about his class that will be available to anybody who's interested, and we'll have a brief musical interlude before we head on into the afternoon to the new movements.